right, this is Mankey's Principles of Microeconomics, Chapter 2 slides, and we'll go ahead and get started here. All right, last time we talked about concepts such as opportunity cost and scarcity, very basic and fundamental ideas to studying economics. And in this chapter, we're going to apply those ideas to another graph. I showed you just briefly with the Subway sandwiches a supply and demand graph, but we're going to talk about a different one today, production possibilities graph. But before that, we're going to look at the circular flow model. So we're going to be looking at two different graphs today. The model is more of a flow chart looking model, and see how those concepts that we talked about yesterday apply to these models. You might remember in high school having to do a science fair project and having to employ the scientific method, which included coming up with a problem, a hypothesis, an educated guess, and then actually completing the experiment and then talking about your conclusions. And although we talked about economics being a social science last time, it's still a science. We still employ the scientific method to problems that we're looking at. Even though we're not working in the lab with chemicals, we're still looking at data. For my thesis, for example, I was looking at what attracts college graduates to certain cities or certain areas. We would call them metropolitan statistical areas. And was it the crime rate? Was it pollution rates? Was it commute time? Was it proximity to entertainment and water? And all of those data I gathered from census data, from data supplied by the FBI, home prices, and you put all of that into a regression model, which is a different one that we're going to talk about today. But you come up with a guess, an educated guess based on the previous research. You plug all that into the computer, and it creates a mathematical model for you. And then I could come up with my solution, or my conclusion. In that case, it was home prices that I found in my study. So economists are called upon, you can see in the past slide, to not only explain the world, so what attracts college graduates to a certain area, and if our city wants that, how can we change policy to promote that? So explaining it and then also making recommendations, two parts, two roles that economists play. All right, to build a model, whether it's a flow chart, whether it's a mathematical regression model, like in my study, we have to make a lot of assumptions. In the real world, there are so many different variables. You'll remember the assumption that we talked about last time, ceteris paribus, which means all else equal, exactly. Everything else equal. We're going to pretend all of that's staying the same, and we're just looking at these two variables at hand. And so in economics, when we have models, of course it's not going to be exactly how it is in real life. It's not going to mirror reality, but we have to start somewhere. So a model, you can think of a plane model or a dollhouse. It obviously doesn't work like the real thing, but it gives you an idea. It gives us a starting place to represent how things work. Okay, the first model that we're going to talk about is the circular flow diagram. You'll remember from last time that a market is a group of buyers and sellers. Remember, it's a more general term. A transaction doesn't have to have happened. But in this model, we've got two markets. The markets for goods and services. In economics, when we talk about goods, that just means a product. Something that you buy at HEB and you bring home. Maybe a t-shirt or a carton of eggs, for example. The market for factors of production, which we'll talk about on the next slide. So there are two markets here. And then households, we mean, just like you and me, consumers. And then firms, we mean businesses, small businesses, private businesses, corporations, any kind of business is a firm. So that's what's included in the circular flow diagram, and we're going to look at how money flows through the markets and how money is spent by these two actors. All right, the factors of production. It's just like it says, what do you need to produce the product? Some of you yesterday mentioned that you were interested in starting your own business someday, and you might go into the service industry. But if you were to decide to go into the manufacturing sector, so think of the factory that you would need to build if you were going to produce a product. What are some things that you're going to need? Assume that you have the money already.
Square footage.
Okay, land.
Supplies.
Supplies.
Equipment to do the actual manufacturing.
Equipment.
Electricity demands.
Good.
Workers.
Workers. Excellent. I think y'all have all of them already. Okay, so the factors of production. Land. It's right there in the middle. Y'all mentioned that. Labor, our workers. Okay, and capital. Just make a note to yourself, in economics, when we're talking about the factors of production, we're not talking about financial capital. This is physical capital. Okay, y'all mentioned supplies. That goes under capital. Equipment. That goes under capital too. Computer, software, that all goes under capital. Because we're talking about physical capital. If you've taken accounting, you might think of the things that go under your assets as examples of what goes under physical capital. So the truck, your machinery, your equipment, all of that goes under physical capital.
The utilities required to take machinery to power machinery. Where does that fall?
That would fall under capital too.
Okay. I wasn't sure if it fall under land because it comes with property.
Yeah, I think that would go under capital because it's talking about the machinery. So all of these three things are what you need to make your product, right? You need the raw materials. That falls under capital also. Those are capital goods. Other economics textbooks include a fourth factor of production, entrepreneurship, or the ideas needed to create a product, but your author just uses these three. Remember, I said to assume that you have the money to do it already. Because here we're talking about the factors of production, the actual thing that's going into the production process on your production line. So capital, if you see this on a test, it does not mean money. All right, so let's put all of these into the diagram. We've got households and firms. Go back here. Okay, households, that's you and me. We buy and consume goods and services. I said goods was like, cereal and milk that we buy from H-E-B and take home. Services are things that are less tangible, like a haircut or an oil change or having somebody do mow your lawn for you. So you don't bring those things home with you, but you still purchase them and consume those services. So obviously we buy those. Also, remember, in a market we've got buyers and sellers. Households also serve as the sellers of the factors of production. And the easiest one to think of is the labor market. Remember we said land, labor, capital. So think of the labor market as the example for this. How many of y'all are working right now and have a job? Okay, you can think of it as you selling your labor and time and experience to your employer, and they are buying it from you, right? You're getting paid for your work. Okay, firms, we said these are corporations, businesses. They buy and hire us in the labor market and then use that to produce their good and service and sell that in the market for goods and services. So I'm going to click through here until everything's shown up. Right, if we're supplying labor in the labor market, that turns into goods and services, if we're following the red arrow here, by firms, and then they get to sell that. So if you see this markets for goods and services, you might just write HEB or Walmart up there and just remember that's what we're talking about up here, and we're thinking about the labor market down here. Those are some examples. Okay, so firms take raw materials such as labor, supplies, turn it into a final product that households can buy. Up here, so we're talking about the red arrows. And when we bring home a good or service, it probably just goes, when we purchase goods and services, where does the money go? And then if you just follow the other way, the green arrow represents where the money is flowing. So when we buy goods and services at HEB and Walmart, that's revenue for those firms that they can spend on materials that they're going to use to produce something and hire people, right? Okay, what happens when people get nervous about the economy? They're not sure about their future incomes. Start spending less on goods and services. What happens here? Okay, that goes down. What happens here? Goes down. We're starting to see some unemployment. And then what happens here? Goes down more. Right?
Vicious cycle.
The circular flow diagram, like I said, a model is a very simplified version of reality. We're missing several actors here in our economy, right? The government, foreign countries, they buy and sell services, goods and services to us too. So this is a really simplistic model of how money and resources flow through our economy. But it really shows how interconnected we are. And if consumer confidence starts to go down, then we're going to see all the rest of this diagram get affected also, be affected also. Okay, so here, who are the buyers in this market? We are, households, good. Sellers?
HEB, Walmart, any place, goods and services.
Okay, firms, excellent. In the markets for factors of production, who are the sellers? Households are, and then the buyers are firms. Okay, so remember, markets, group of buyers and sellers. Just remember these two markets, who are the buyer and who are the buyers and sellers in each market, and where the money flows. I remember as a student, I had to draw this out for several tests. I'm not going to have you draw it out, but I'll ask you questions like I just did. Who's the buyer and the seller? What roles do we play in each market? Everybody's in good shape? This diagram? All right. We'll put this slide up here, and then we'll switch over to the video. The production possibilities frontier is the second model that we're going to be talking about. Okay, again, model is a simplified version of reality. What we're assuming here is that a country or an economy, a society, whatever you want to call it, is producing two products. Now, of course, in real life, America produces way more than two products, but we're just going to keep it simple. Two products, and we're looking at how they can allocate their resources in terms of what combinations of those two products they can make. And that's what this graph represents, all the different combinations of two products an economy can make. Actually, I'm going to show you one thing before I shift over to the video. Everyone's got this slide? Okay, before we talk about production possibilities, it might help to think about consumption possibilities since we're consumers. Okay, let's pretend that you had $2 in your pocket. It's all you have in your pocket, and it's lunchtime. And you're going to go unhealthy today. You're not going to eat very healthily. Now let's pretend downstairs in the bookstore, they're selling Coke for $1.50 for chips. What are some different options? What are some different combinations of consumption that you can consume with $2?
2 bags of chips and a Coke.
Okay, 2 chips. 1 Coke. What else?
2 chips.
And
No chips.
0 chips. Actually, I'm going to rewrite that so I've got it consistent. What else? Okay, 4 chips, 0 Cokes. Okay, and if I were to graph all of our different combinations over here, I'm going to put Coke over here on the vertical axis, chips over here on the horizontal axis. Okay, this first option, 2 chips and 1 Coke. It's that point right there. This next point, 0 chips and 2 Cokes. Right there. 4 chips and 0 Cokes. Right there. All right, if I connected the dots there, that line just represents all the different, it connects all my different consumption possibilities, right? Why can't I consume 4 chips and 2 Cokes? Why can't I get out of there? Well, you don't have enough money. You can get there if somebody lets you borrow, maybe a couple bucks. What does that mean?
But you'll have money left over.
You didn't spend all of your money yet, right? All right, so y'all see the differences, or y'all see the relationship to yesterday's concepts. Scarcity, because you only have $2, you have to make choices. This just represents all the different choices that you have. And there are trade-offs, because you've got limited resources. You start off with 2 Cokes, that's fine, but if you want some chips, you're going to have to give up a Coke. And so those are some basic concepts that we're going to apply to the production possibilities frontier. So let me come over here. We'll get started on this.
The production possibilities curve, a big favorite of economics textbooks, for good reason. The production possibilities curve, or frontier as it's sometimes called, turns out to be a very simple way to illustrate 4 very important economic ideas. First, it's another demonstration that economics is based on the idea of scarcity, of trade-offs. So imagine a fictitious economy somewhere that makes only 2 goods, pizzas and robots. For the sake of clarity, economists like to make their models as simple as they can, and it doesn't get much simpler than this. Anyway, this economy's only 2 goods are about to be put up on a table, which represents the trade-off between them. Devote all this simplified economy's resources to making robots, and let's say it can make 10,000 of them. But that means no pizza. Making just 1 pile of pizzas, the table shows, means making fewer robots. And as more pizzas are made, the possible number of robots is further reduced, down to a situation of all pizzas and no robots at all. Put the different combinations on a graph and you've got the production possibilities frontier in action. So if you're willing to go without pizza entirely, that's 0 down here on the x-axis, but you can make a full 10,000 robots here on the y-axis. So production possibility A, up there. Possibility B involves making at least some pizza, on the table 100,000 pies. But that means we only have the resources to make 9,000 robots as well. There's also possibility C, possibility D, and this frontier ends down at possibility E. 400,000 pizzas, no robots at all. The picture looks the same for any two products. The author of The Economy Today, Brad Schiller.
If we want to look at production possibilities at work in a real setting, just look at the issues that the United States is facing right now. Every public opinion poll shows that Americans want more homeland security and more national defense, without question. Democrats, Republicans, everybody wants it. But where are we going to get it? I mean, think about it. If you're going to deploy, say, our police forces to guard buildings and bridges and airports, what are they going to stop doing? We're making a difficult choice.
So why don't we simply hire more police?
It would be wonderful if we had more police. We already have 640,000 police officers in this country. And sure, we could get more, but where are we going to get them from? We're going to have to take them out of some other industry. We're having the same problem with the war in Iraq. We have to call up tens of thousands of National Guardsmen who would otherwise be producing goods in the civilian sector, teaching in schools, working in construction, working as accountants. These are the National Guard who are weekend warriors. Suddenly we take them out of their civilian jobs in order to strengthen our national defense. We're making a choice. We're moving resources from the production of butter, civilian goods, to the production of guns, our national security.
It was after World War II that economic textbook writers started using guns and butter to illustrate that there was a trade-off between consumer goods like food and military hardware. The reason behind the trade-off, as Brad Schiller says, is that you have to use finite resources like land, labor, and raw materials to make anything. Again, say, pizza and robots. If everyone in the economy is toiling away in the robot factory, there will be no one left for the party. Okay, that's the first lesson of the production possibilities curve, the economic notion of scarcity. Anything you make costs you the opportunity of doing something else with the same resources. That is, their opportunity cost. The second lesson of the production possibilities curve is a little more subtle. That the more you make of anything, the greater its opportunity cost. Go from making 0 robots to 4,000 of them and we get quite a payoff. What does it cost us in terms of pizza? The chart makes it clear. 100,000 fewer pizzas. Or to put it another way, minus 100,000 pizzas divided by 4,000 robots. So the first 4,000 robots cost an average of 25 pizzas per mechanical man. 4,000 goes into 100,000 25 times. Since it's minus 100,000, that means minus 25. The minus sign simply says this is a cost, a subtraction from what we had. But look what happens when we go from 4,000 to 7,000 robots. This time we only get 3,000 more metalheads. But to produce them, we still have to give up the opportunity of making 100,000 pepperoni specials. So again, minus 100,000 pizzas divided by a mere 3,000 robots, an opportunity cost of about 33 pizzas per robot. And when we go from making 7,000 to 9,000 robots, the extra 2,000 automatons still costs us 100,000 foregone pizzas. Therefore, the opportunity cost increases again. 100,000 pies divided by 2,000 cyborgs, 50 pies per board. Finally, the last segment of the production possibilities curve is the costliest in terms of orders from Domino's. The last 1,000 androids cost the economy the same 100,000 pizzas, but at a whopping rate of 100 pizzas per robot. And if you spend a little more time on this graph, you can see that the same increasing opportunity costs work in reverse. The first 100,000 pizzas cost 1/10 of a droid per pizza. The last 100,000 cost 4 times as much. Thus, the law of increasing opportunity cost. But what's driving it? Why is the production possibilities frontier concave to the origin, meaning it bows out from the place the two axes meet, like a cave or cavity? It's because things tend to cost more to produce the more you produce of them. Again, take the example of guns versus butter. Economist Cecilia Conrad explains.
At first, we can move the resources that actually tend to be better suited for producing guns. The people who are, perhaps really good at putting together, I'm not sure what it takes to produce guns these days, probably putting together electronic circuitry. We move those people first on the production of guns, so we can start producing guns at fairly low cost. But as we try to move more and more away from food towards guns, then we're going to eventually have to start to bring in the people who really spent all their life out on a farm somewhere farming and don't have any idea about how the industrial process works and aren't really adjusted to working on an assembly line. And so the cost of getting the extra gun production is going to start to get higher.
And that means?
And that means that we're going to have to give up more and more butter to get the same incremental addition of guns.
And similarly going
the other direction.
Another way to look at it is that you use your cheapest resources before any others. Or to use an old economics cliche, you pick the lowest hanging fruit first. Economist Jim Clark.
They go for what you can get most easily, for what has the lowest opportunity cost. When I talk about grabbing low-hanging fruit, it's just right there. You just reach up and grab it, and it takes hardly any effort. You didn't have to give up very much to get it. If you want the fruit at the top of the tree, you've got to haul out this big ladder and climb all the way up, and then maybe you can still reach it up at the top, but it's going to take you 10 or 15 minutes to get it and a lot of equipment, and if you don't have a ladder yet, you've got to build a ladder. So you want to pick the alternative that's got the lowest cost in terms of other things that you have to give up. So the low-hanging fruit's the stuff that's easy to get.
In other words, all producers start with the easy pickings. Now, there are arguments about how true this is in every case. For example, aren't computer chips cheaper the more you make? But in a competitive market, economics assumes that opportunity costs rise with quantity because of the low-hanging fruit phenomenon. So where are we? Thus far, the production possibilities curve, or frontier, has illustrated both the idea of trade-offs, that is, scarcity, you can't have it all, and the idea of increasing opportunity costs. There remain two more key points about the curve, but we'll get to them in the next video.
We're just going to watch that first one, and we'll start the second part. I'll tell you what they talk about in the other ones. Actually, let's come over here. How many of y'all have toured the M&M Mars plant? All right, what do you remember about it?
Everything. My dad works there.
Okay, so for those of us who haven't been there, tell us what it looks like, smells like.
It's just part like chocolate. Like it doesn't smell really good. It smells like crap almost. Like it's weird. It has a weird smell. Like it doesn't smell like chocolate, but like I don't know. It's just weird. You just see a bunch of rows of like conveyor belts, like with rollers on it, with boxes just going down circles. I mean, it doesn't look like Willy Wonka factory at all. I was bummed out, but like you know what I'm saying, one of the Oompa Loompas, but like I don't know. It's just me. It's really really loud. But like it's not a magical place or nothing. It's pretty factory stuff.
Yeah, definitely. You feel like you're in Sam's. It's a big warehouse, and it's very loud. It's really, really hard to get in there to take tours now. I know they're. But what candies? What do they produce there?
Skittles, Snickers, I think like Milky Way maybe. I think that's it there. They don't do anything like that.
Right. I think they do Starburst.
Yeah,
too.
Starburst.
Okay.
Yeah, Starburst.
I couldn't remember. I know they do several there. Maybe Snickers, Crunch. So instead of Coke and chips like we had over here, we'll just pick two of those. We'll say Snickers and Starburst. Right. And we're talking about M&M Mars. Here we were limited by cash with our $2. M&M Mars is limited. What are their scarce resources? What are their factors of production? Let me know what those three are. Land, labor, and capital. If they were to use all of those efficiently, remember when we bought 2 Cokes, we were using up all of our $2. I know we were assuming it was tax-free over here. So, using up all of our $2. If M&M Mars decides to use up all of their land, labor, and capital to make only Snickers, that would be represented by this point, right? Well, let's just pretend that's 100 Snickers and 0 Starburst. If they decide that people want some Starburst and they can make some money by producing several different kinds of candy at that factory, what are they going to have to do to their level of Snickers?
Reduce.
Reduce it. Why?
You have more people and resources going for the Starburst.
Keep going. We've already used up all of our machinery, all our workers here, right? So we're going to have to switch some of our resources over to Starburst production. So you have to produce less. Just like here, if you wanted some more chips, you're going to have to give up Coke because you'd already spent all your money. Here we've already used up all our resources, so we're going to have to give up some Snickers production for some Starburst production. Okay, if we want even more Starburst, have to continue giving up Snickers, and then we'll put a line right here, a dot right here, just to represent only Starburst production and no Snickers production. I'm going to connect the dots here. This represents a production, possibilities, curve, or frontier, either one. Who remembers from the video why it's shaped differently? A lot of things are the same. It represents, if we're on the line, it represents efficiency. We're using up all of our resources, just like here we used up all of our money. Represents scarce resources and those trade-offs between Snickers and Starburst production. Why is it shaped differently? Yes, what kind of opportunity costs? Increasing opportunity costs. Kid Maggie, the law of increasing opportunity costs explains why it's shaped that way. Okay, y'all remember from last time, what's an opportunity cost?
What you give up.
To get something else. What you give up to get something else. Okay, that means you're giving up more and more and more Snickers to get more Starburst. Okay, let's put some numbers on here. Let's pretend that this is 25 down here. So to go from 0 to 25 Starburst, let's pretend that we gave up 10 units of Snickers. I'm going to make my dot a little bit bigger so it's more to scale. Let's pretend that's 50 right there. So to get an equal number of units, an additional 25 units, see that vertical distance? Much bigger than this one, right? Let's pretend that's, we'll say 60. So you gave up 10 here. Here you're going to give up 30. And then here, let's just pretend that's 75. So for equal units of Starburst, you're going to have to give up more and more and more. And that explains the shape. What does that mean in real life? Okay, you mentioned that your dad worked there in the factory. There, it is all automated. Isn't it amazing, all the technology that you have there? Conveyor belts, like you mentioned, they use gravity. People aren't there mixing up the chocolate for the Snickers bars. It's in a huge vat. The chocolate's flowing down this big, huge conveyor belt. They're using gravity to spread it all out, and then other layers. Only thing that people have to do is stand at the end of the conveyor belt and pack it up into those big boxes that you can buy at Sam's, right? All of it is done by machinery. So you have very specialized machinery in Snickers production. Is it easy to make Starbursts out of machinery that you've just used for Snickers? Okay. We've got all sorts of ingredients, all sorts of layers in a Snickers bar. What do we have in a Starburst?
Pretty much just a mold of like
Taffy.
It's just this taffy stuff, right? It's different. It's in a different part of the factory, it's different machinery. Whatever flavor they're working on, it's in this big vat that they're mixing up, and then it just turns it into little squares. So what are we saying here? Maybe we can move some mixing equipment, maybe we can use some workers and shift them over from Snickers production to Starburst production. But if you want to use more and more and shift more and more of the machinery and equipment, then you're going to have to give up more. And the reason why we have a lot of increasing opportunity costs in real life is because we have such specialized machinery and manufacturing processes. Okay, so points A and B, what do those represent? Oh, you can't see them, huh? Let me switch back over here. Okay, this is figure 2 from the book. Points A and B, what do those represent on the line?
Possibilities of the
Those are possibilities of production, and we call that, if they're using up all their resources,
efficient.
efficient. Those represent efficiency. Just like you were spending all your money, these represent M&Rs using up all their resources. What does point C represent?
Something that's outside of the capability.
Unattainable. Y'all remember I asked you when we were looking at the Coke and chips, I said, why can't we consume 4 bags of chips and 2 Cokes? I said we didn't have enough money. Here, we don't have enough machinery, equipment, resources to produce at C. As of right now. If we get more machinery, more workers, that's great. We can shift the whole thing out. If you were to shift the whole thing out by getting more workers and machinery, that blue line, remember I showed you that shift last time with the Subway sandwiches? That's what we want. That represents economic growth. But with the resources that we have right now, we can't get there. Okay, what does point D represent? Inefficiency. You're not using up all of your resources. Just like if you bought just 1 bag of chips, you wouldn't be using all of your $2. So point D, is it attainable? Sure, we can get there. It's just we're being inefficient. Okay. And this slide just summarizes what we were just talking about. So if you're at a point like point D, inefficiency, what does that mean in real life? Maybe some of the machinery is broken down. Maybe there's new management and people aren't listening to them. Maybe people are taking longer breaks than they're supposed to. Maybe we've got a whole bunch of people on strike. You've got workers, but they're not producing anything. They're not working. So those are some real life examples for this middle one, inefficiency.
Can I throw something? Okay. I got a quick question.
Okay.
In companies like Mars, they run these type of statistical data? Do you know that they run this type of stuff?
They're running data all the time with their production. Yeah, with their quality control. There's their computers in any manufacturing facility.
Well, I'm just thinking
they've
of
got,
the production possibility. I mean, relative to...
They do.
yeah, they're absolutely. They've got statistics going, gathering data all the time on their production processes.
Yeah, because I know working where I work, we had charts of all over, like by where I worked, like graphs and all that stuff, projected growth percentages and what Walmart might buy or who's going to buy,
Mm-hmm. Yeah, absolutely.
Companies buying out each other, so we're going to try to bid jobs and net our growth. It's a lot of them now.
Mm-hmm. Definitely. All right. And then just to sum up, we've got some concepts that we've talked about with the slides that we've talked about earlier. So, is everybody in good shape with the production possibilities curve? What it represents, what it shows, the shape of it. We want it to shift outward, but we can't get there unless we have an increase in one of those factors of production. We have several other examples in the PowerPoint about the production possibilities curve, but I think we've talked about several examples. I'm going to skip over here to this slide, 18. So a couple more definitions. I mentioned this yesterday? Well, I talked about microeconomics. We're going to be talking about things like an analysis of consumer welfare. We're going to be talking about how firms make decisions when we talk about different market structures. Macroeconomics deals with issues that are nationwide, like unemployment and inflation. So they're different in that way. Well, other definitions. Positive and normative statements. So make sure you know the difference between this. Don't think of positive as in positive and negative, like good news and bad news. Think of it as it's defined here. Positive statements describe the world as it is. So it's factual. It describes some kind of relationship, some mathematical relationship between two variables, like we talked about the positive and or inverse relationship, or positive and direct relationships. We talked about two variables last time. Normative statements give some kind of value judgment. We're talking about how things should be. So if I say the unemployment rate is 7.5%, would that be a positive or normative statement?
No.
Positive statement. Now, I know as you normally define positive, that's not really good news, right? But it's derived from data. You can prove it. It's just how it is right now. Who can think of an example of a normative statement about unemployment?
Unemployment should be at 3%.
Should be at 3%. Okay? Who can think of another example?
I should be employed.
Everybody should have a job. Who wants one? The government should do something about the unemployment problem. So if that word should is in there, that's a dead giveaway. But if there's any kind of a value judgment, then you know that that's a normative statement. Again, going back to the two roles that economists play, describing the world how it is, and then also being called upon to make policy recommendations. So as, here, as scientists, we make positive statements, and as advisors, we give normative statements. Okay, the rest of the slides, we've got some more examples about positive and normative statements, but your author does mention at the end of the chapter, why do some economists sometimes give conflicting policy advice? Now, it really just depends on their perspective. So if they're thinking about the short run or the long run, sometimes their priorities. And remember we talked about the principles last time, so these are general rules that most economists agree on. Well, at the end of this chapter, your author just goes through some propositions, some things that most economists agree on. And he actually gives percentages of a sample. But we'll talk more about price controls in chapter 6. And international trade in future chapters. But those are just some examples about some propositions in which most economists agree. And that is the end of chapter 2.